In this screencast, I'm going to show you how to use a few of the tools that I've included in my orbital motion lesson plan. Here's my lesson plan. Under this section, use math and computational thinking. I ask students to create a graph comparing distance from the sun and orbital speed using this tool. So I'll click here and it will take me to this create a graph. I instruct students to select the XY portion and then to go to the data tab. Here I can give titles to my graph, like distance versus orbital speed. For x-axis, I'm going to label it distance from the sun, and for the y-axis, the orbital speed. I don't have a source, but I'm going to manually put in my sources. I do have 8 points of data, so I'll select 8, and then I'll start. I've provided the table for students here. So for Mercury, I'll put 58 and 48. And then I'll just go back and repeat the process for each planet. Alright, now that I have all the data in, I go to the preview, and that will show me the graph that I've created. Hopefully students will clearly be able to see that as a planet's distance from the sun increases, its orbital speed decreases. The other tool that I provided for students is this computer simulation that allows students to see how the mass of a planet affects its orbital motion and how the mass of the sun affects its orbital motion. So I'll click here on this. I'm going to select the model mode, and I'm going to keep using the Sun-Earth model. And what I'll do is I'll simply hit play, and I can watch the sun orbit once around the Earth. I'll include the path just so we can see it. And down here it tells me how long it takes for the planet to orbit the sun. We'll click on fast forward just so we can observe it a little bit faster. And as we round the first orbit, we can see that it takes about 365 days for the planet to complete its orbit. Now what I want to do is I want to change the mass of the planet. So we'll make the planet smaller, and we'll see how that affects the orbital period, how long it takes for the planet to orbit the sun. All right. And hopefully now you can probably see that as we round about the last quarter of our orbit, that the orbital period is still about 365 days. And we can observe the same thing if I change the mass to even bigger than that. We'll clear this and restart. Now the planet will have 1.5 times the mass of Earth. And again, we see that by changing the mass of the planet, I'm not actually affecting the orbit of the planet. So now what I want to do is I want to change the mass of the sun at the center. And so if I change the mass of the sun to 0.5 to half as big as it is now, we'll observe the motion of the planet, and we see that the planet leaves orbit. The gravitational attraction from the sun is not strong enough to keep the planet in its motion. And so now I will make the orbit, or make the mass of the sun 1.5 times bigger, and observe the orbit of Earth. I can see that as the planet gets closer to the sun, it increases its orbital speed, and its orbital period is almost more than 150 days shorter, so it's definitely moving faster. And again, I'll restart it, and this time I'll make the mass of the sun twice as big. And we see that the Earth crashes into the sun. Now the sun is too big, its gravitational attraction is too large, and the Earth cannot maintain its orbital motion. So there's just 2 of the tools that I've decided to use in my lesson. Hopefully these tools will help students to recognize patterns, correlations, and also to see what causes and affects orbital motion in our solar system.